In this video, we're going to practice solving a system of linear equations where the coefficients are fractions. We'll explore two techniques. We'll start with the substitution method, and then we'll move on to the elimination method. Here we have a system of two linear equations. As you can see, every single one of the coefficients for the variable x and y is a fraction. So our first step in both methods will be to clear those fractions. So how are we going to do that? We do that by finding the least common denominator for each equation and multiplying the entire equation by it. This simple step will transform these messy fractional equations into the straightforward equations with integer coefficients. So they're going to be much easier to solve, right? So let's start with the first equation. The denominators are 5 and 8. Because they don't share any factors, the least common denominator of these two numbers is simply their product, right? So 5 times 8 is 40. So this is the least common denominator for equation 1. Then we'll multiply in both sides with this 40. All right, so for equation 1, be careful here. When we multiply 40 to the left side, we need to multiply it to the entire expression. The expression on the left is 2 over 5x minus y over 8. And it equals to negative 1 multiplied by 40. Now we distribute the 40 to each term in the brackets. So we have 40 multiplied by 2 over 5x minus 40 multiplied by y over 8. And on the right side, we just have minus y multiplied by 40, which gives us minus 40. For the first term on the left, we can cancel the denominator by dividing 40 by 5. That gives us 8. Then we have 8 multiplied by 2x, leaving us with 16x. For the second term, we cancel the denominator by dividing 40 by 8, which gives us 5. So we have 5y for the second term. Then equals to negative 40. So now we have cleaned our first equation. Now let's follow exactly the same process to clean the fractions in the second equation. In the second equation, the denominators are 2 and 4. So the least common denominator of 2 and 4 is 4, right? So we multiply 4 on both sides of the equation. We have 4 multiplied by the entire expression on the left, which is x over 2 minus y over 4, then equals to 4 multiplied by 3. On the left side, we distribute 4 to each term, giving us 4 multiplied by x over 2 minus 4 multiplied by y over 4, then equals to 4 times 3 is 12. Now let's simplify the left side. The first term can be simplified by dividing 4 by 2, which is 2. So it simplifies to 2x. And then the second term, these two 4's cancel out completely, leaving us with simply y. And then on the right side, we have 12. So this is the second equation after cleaning the fractions. Now there are no more fractions for these two equations, and this is going to be a much easier system to work with. Now let's write them together down here. For the first equation, we have 16x minus 5y equals to negative 40. And for the second equation, we have 2x minus y equals to 12. First, let's try to solve it using the substitution technique. To use the substitution, we need to isolate one variable in one of these equations. And the second equation looks like the easiest choice because we can easily isolate y. So let's write it down here again. Let's move y to the right side and 12 to the left side to get a positive y term. So let's add y on both sides and subtract 12 on both sides. This gives us, on the left side, we have 2x minus 12 because negative y plus y is 0. And then it equals to y on the right side. We can rearrange it as y equals to 2x minus 12. Now we have an expression for y. The next step is to take this entire expression and substitute it into equation 1 wherever we see y. In the first equation, we have 16x minus 5y. So now we take this expression and replace this y as 2x minus 12, and it equals to negative 40. Now we have a single equation with only one variable x. To solve for x, the first step is to distribute this negative 5 across the parentheses. So the first term is still 16x. Then we distribute the negative 5 to each term in the parentheses. So negative 5 multiplied by 2x is negative 10x. And negative 5 multiplied by negative 12 is positive 60, right? A negative number multiplied by another negative number give us a positive number. So it's positive 60. And on the right side, we have negative 40. Now let's move all the numbers to the right side. So we subtract 60 from the left side and also subtract 60 on the right side. So we have 16x minus 10x equals to negative 100. Now 16x minus 10x is 6x. It equals to negative 100. Finally, we divide both sides by 6 to solve for x. So x is negative 100 over 6. We can simplify this fraction by dividing both the numerator and denominator by 2. So eventually we get x equals to negative 50 over 3. Now we need to find the value of y by substituting the value of x back into the isolated equation, which is this one. So y is 2x minus 12. We substitute this negative 50 over 3 for x, then minus 12. So first we multiply this 2 by this fraction, giving us negative 100 over 3, then minus 12. To combine these two numbers, we need a common denominator, right, which is 3. So we can rewrite 12 as 12 times 3 over 3, right? So we still have this negative 100 over 3. So this equals to negative 100 over 3 minus 36 over 3. Now we can combine these two fractions. They share the same denominator, 3. And we combine their numerators, negative 100 minus 36, which equals to negative 136 over 3. So the solution for this linear system is negative 50 over 3, which is the value of x, and negative 136 over 3, which is the value of y. Now that we've solved the system using the substitution technique, let's solve it again using the elimination technique to check our answers and see an alternative approach.